Welcome to Lab 3. Today we are going to be talking more about how to generate descriptive statistics, as well as a little bit about data manipulation. For today we're going to be using two different data sets. We're going to be using the Lab 2 data from last time, as well as the Lab 3 data. So you're going to want to download both of those. We're going to first open up the Lab 2 data. When you open up Lab 2, you'll be in your variable view, and you'll see that we still have the subject and the enjoyment variables. Again, these were data about how much do I enjoy statistics, and people could rate it on a scale of 1 to 6. So we have some people who are on the 1 end, that one person at the 6, a couple of people at the 5. And last week we looked at the frequencies, so let's go ahead and do that again. We go to Analyze, Descriptive Statistics, and Frequencies. This will pop up a window where we can move over enjoyment, and we'll see that there's going to generate some descriptive statistics such as the mean, the standard deviation, minimum, and maximum. As we learned last week, these are the default values. Of course, we can change these at any time, but for right now we're not going to. We just want to see the stats pop up. So click OK. This will open up our output, and here we see the mean, standard deviation, minimum, maximum, along with our frequency table indicating how many times each participant responded on one of these metrics. And here you'll see we generated our mean of 2.8, but now we have the standard deviation of 1.47, which should mean something to you. The standard deviation is just the average deviation, the average amount of differences from the mean for this sample. So the average amount that people differed from a 2.8 is about 1.47. Now there's a second way that we can generate our descriptive statistics. So if we go back to our data, we do this by clicking Analyze, Descriptive Statistics, but this time we're going to go to the Descriptives list. That'll open a pop-up. And here we'll see a similar kind of window that has the potential variables on one side. You can move them over to the variables you actually care about here, as well as indicating what type of statistics you want. So let's again move enjoyment over. And we still have our statistics of the mean, standard deviation, minimum, and maximum. And we have a couple of other options which we're not going to deal with today, but they are going to come into play later on. But let's just leave it at this with the enjoyment with these 4 default statistics and click OK. This will go to our output. And here you see we have our syntax descriptives \variables equals enjoyment, which is very similar to what we learned last week about frequencies and having the variables. But there's no other line. Instead, we are automatically given a table that includes the statistics, but they are laid out horizontally. Whereas in the frequencies, they were listed vertically here. Now we have these horizontal numbers. And as you add more variables, maybe we have more than just the one variable, these will stack. In fact, if we go back to Analyze Descriptive Statistics, Descriptives, and we include our subject, again with the mean, standard deviation, min, and maximum, click OK. We'll see that they just stack right next to each other. And the reason we like this in statistics a little bit more than the frequencies is because you can have lots of variables and just kind of quickly see all of the means and standard deviations. You'll also see here that in the descriptives variables, it's defaulting to using the mean, standard deviation, min, and maximum. Just like last week, if we go to Analyze, Descriptive Statistics, Descriptives, and we change any of these, maybe we want to get rid of the min and maximum, and instead we want to add the range and maybe the sum. Now we'll see that it changes. We have mean, standard deviation, range, and sum, again horizontally, as well as this extra line in the syntax, \statistics equals mean, standard deviation, range. And so if we go to our syntax, maybe we want to file new syntax, we could type this in, descriptives, variables equals enjoyment, And this time, let's say I just want the mean and standard deviation, so I'd type mean and std dev, just like we have here. So I'm ignoring the range and the sum. Want to make sure I put that period at the end, very important to have the period, and then I'll run all, go back to my output, and see here I've generated the mean and standard deviation of enjoyment. So now that we've seen how it works with the data we've already interacted with, we're going to open a new file. We're going to open the lab 3 data set. Our variable view shows us that we have 3 variables. We have a variable for time and for appreciation. The data we're looking at today is going to be the data from class about the poetry lessons that the teacher gave with 9 students that were representative from the before the poetry unit and 9 students after the poetry unit. And so you'll see laid out here I have my time variable and I have 1s and 2s. In my variable view I have already assigned these that 1 will equal before and 2 will equal after. 1 before, 2 after. If I go to my data view, I can see that by clicking the labels, the show hide value labels toggle, and I'll see that I have 8 from before and 8 from after, not 9, 8 of them. And you'll see I have that there are 16 different participants. I did not double them up. It's not the same participants going at time 1 and time 2. We're just going to count them as 16 individuals. So if I want to generate descriptive statistics off of this, I could go to descriptives and maybe I just want the frequencies of the time variable. So I'd go in here, click the time. You know, I could set these, but let's leave those alone. Click OK. And here my output, I have frequencies, variables equals time, the format for a table, and the statistics just the mean and standard deviation. Here we go. This is my frequency table for the time variable. And as you see, I have 8 subjects from before and 8 subjects from after. The mean of these numbers was 1.5 because I had 8 1s plus 8 2s. But we know that with a nominal variable such as time, right, because time, the order, I guess it's an ordinal variable here, but mean doesn't mean anything when it comes to an ordinal variable. You can't have 1.5 times in this situation. The standard deviation of 0.52 also does not mean anything here, right? So this is less useful. What would be more useful is getting the frequencies and the distributions for my appreciation score. So let's do that with descriptive statistics. And this time I want to use the descriptives window, not the frequency window. So analyze descriptive statistics, descriptives, and I'm going to move over my appreciation. I don't want the mins and maximums. I'm just going to keep it with the means and standard deviations. And I'm going to click OK. Go to our output. And here we see I have the codes descriptives / variables equals apprece, the name of my variable. And the statistics I'm looking for are the mean and standard deviation. We see here that we have 16 subjects, a mean of 5, and a standard deviation of 2.71. Now, of course, the intuitive of you will notice that something's wrong here. And that is that in the original problem, the 8 people from before and the 8 people from after were separate. And we got 2 different standard deviations and 2 different means because they were at 2 different time points. So the fact that we ran the descriptives with all of the appreciation, we just typed it in just to get all of the data, it's going to include them all together. It's going to count all 16 of them simultaneously. In other words, it's going to ignore the fact that there is a before and after. It ignores that time variable. It doesn't care that 8 of them were at time 1 and 8 of them were at time 2. So we're actually going to have to figure out how to get around that. And one way is by using what's called split file. A split file takes your file, determines that based on some variable or some condition, it is going to give you different output based on those values. So what we're going to do is we're going to tell PSPP to give us different descriptive statistics based on this time variable and based on whether they scored a 1 or a 2. The way we do this split file is going to Data and Split File. This opens up a pop-up window that is currently set to analyze all of the cases. Do not group my data, do not group my output in any way. But we want to do that. We want to organize our output by groups. And the groups that we care about are the time groups. So we're going to take our time variable, move it over, and this is going to say that for each value of time, so a value of 1 or a value of 2, or if there was a value of 3, 4, 5, for each different value of this variable, create a different output. So, groups equals time. Okay. Now you won't see anything happen yet, but if you go over to your output, you will see that it now has a new code to sort your cases by this variable and then split your file, separate it by time. Now, if we go to that descriptive statistics like we did before, descriptive statistics, descriptives, we still have appreciation and our mean and standard deviation. We can click OK. And now in our output, we'll see that it has two different sets of output. In the first, we have split values. The variable time of the assessment, or our time, equals before. And we have our new appreciation data of a mean of 5, which we calculated, an n of 8, which we know there are only 8 people taken from the before sample, and a standard deviation of 1.2, just like we calculated. Then we also have the split values for after, again a mean of 5, n of 8, and this time a standard deviation of 3.78, exactly like we calculated. And again, we got these two separate instead of just together because we had decided to split. Now, you might be interested in knowing all of the different groups, or you might be interested in only knowing about some of your data, about one of the groups. Maybe you only want to see the data from the before condition, and you don't care about after. You could certainly run it the way I've shown you and just ignore, don't even look at this data, forget the after, and focus on just this data. But I'm going to show you a second way, and this is a select cases. Also as a note, let's go back to the split file, because currently it's still set at this, and we're going to go to analyze all cases again. We want to clear that. We are going to select that only the before variables are included. And the way PSPP does this is we have to set a filter variable. So we'd go to Data, and we'll go to Select Cases. We get a pop-up window, and as you'll see currently, all cases are selected. But we are going to want to use a filter variable, and we could choose any of these filters. The way a filter variable works is that if the filter variable is equal to 0, it will ignore that variable. So if we had any of these time that were set to 0, it would ignore. So I'm going to click OK. And when it ignores, it'll actually give a slash through the number here. We'll see that in a minute. But right now, it's not actually doing that. It's not ignoring anything because none of these time values are set to 0. So really, that filter doesn't affect us. What we need instead is that if we only want to look at the before, these 8 before, we need to set all of the other variables to be 0. In other words, we need to change these 2's to equal 0. Now we could just go through and type in 0's instead of 2's so that it would filter them out, but I'm going to go through a special step. The way we're going to do this is go to Transform. Transform is when we are going to actually manipulate our data. So the data was just to change what we're looking at. Transform is to start manipulating it, and analyze is to find out some interpretation of our data. So I want to manipulate my data. I want to change something in the data set. For transform, I want to change or recode some of the values in my time variable to be different values. So I'm going to look through here, and I'm going to go to recode into a different variable. The way recoding to different variable works is I tell it what is my old variable, in this case time. And I want to tell it to turn into a new variable. I'm going to call this before. And I'm going to say this is before scores before poetry unit. Poetry unit. And I click change. You'll see the variables. The old one is going to be time, the new one before. I then have to set what I want to change the values into. So I'll click the old and new values. And here on the left, I'm going to set the old value. So maybe I want to change the before here, the 1. And the new value, I'll keep it the same, just a 1. And I click add. So now it's telling me that if time had a value of 1 before, now it has a value of 1 after. The before variable, this new variable, will now get a value of 1. Then I want to take the 2's, the after value, and I want to change this to 0 because I want to make sure that it is going to be filtered out. Again, the select cases is going to filter out anything that has a 0 score. So I'll click add. Now I have my settings for this new before variable. Click continue, and I click OK. And what it did was generate a new variable here with 1s for all of my participants at time 1 and 0s for all of my participants at time 2. Now if I go to the select cases and I change it to not filter by time, but to filter by the before variable, I will see that it's going to cross out or indicate that it is going to ignore all of these zeros. All of these zeros. So all of my afters are left out. I then go to Analyze, Descriptive Statistics, Descriptives. I could still do for my appreciation, but this time when I run this Descriptives, it's only going to take the ones that are not X'd out. And I scroll down, and here I see Descriptives, variables equals appreciation, statistics equals my mean and standard deviation, and I only get the data for the 8 participants at time 1 with a mean of 5 and that standard deviation of 1.2. Again, this looks exactly like what we have up here, but now ignoring all of the time 2 individuals. We can also look back through the syntax that was generated here and see how this was done. You see here, this is where I turned the split file off. Remember, I kind of jumped in and undid what was done up here. But then the actual recode is taking this recode, putting the first variable, and in parentheses, you're going to put the before value and then the after value, the old value and the new value, into your new variable. So recode the variable time. Here's how I want to recode it, and I want to turn it into this other variable. And then you would filter by that second variable. So if I want to go into my syntax, I could do this for the after. So let's go back here, let's open a syntax file. And I'm going to type in recode. And this time I want to have all of my after variables, anybody who scored a 2 on the time variable, so who is from my second time point, I want to recode into, keep it as a 2, but all of the befores make a 0. So I have time, and I'm going to take all of those 1s for before, turn them into 0s, and all of the 2s, and I'm going to change this into the variable after. Run. And now I'll see that I have this new after variable, where 0 for all of the befores and 2s for all of the afters. Now you'll see that the filter is still set to ignore all of the 0s for before. That's because we haven't changed anything in the data select cases. In fact, we go here, we'll see that it's used filter variable before. So I want to go to my syntax, and I'm going to type filter by after. Run. And now when I go back here, I'll see that it has filtered out any of the scores of 0 for after have been removed or have been X'd out. Analyze descriptive statistics, descriptives. I still want appreciation, but this time it's only going to give me the 8 participants who are not filtered. So it's only going to give me these guys. Okay. And now I go down. I'll see that I have my descriptives, and this time we have that 3.78 standard deviation, just like we saw before. And that's how you manipulate. Now remember, after you do any of this, you always want to go back and reset. So you can click the reset button to make sure it's at all cases. You could also just click all cases and OK. And it'll go back to how it was with everybody together. We still have our before and after variables, but now we are not manipulating or editing what we see. So if I went back to analyze, descriptive statistics, descriptives, and I got that appreciation, I would once again see I have those 16N and the 2.71 standard deviation. And that's it.